We're live, day 21 of Advent of Code. 40 minutes to go, and we do still have some some review and refactor due on the last couple of days. So there's of course this one, yesterday's problem. Uh, Definitely a lot of this was done by hand. I think I can make that programmatic, but um, we'll get there. We'll get there eventually. Um, hey, Alka, how's it going? Good to see you. I still have a few edits to make to that article I was working on, so I'm going to pull that up. It's not this. Um, the code for day 17. I just switched just to using a map instead of a set. That way, my state here no longer needs to include the accumulated heat loss. And I can just put that, the state itself can now be the key for discriminating future states. I have an article on that, so let's pull that up. You figured it out last night. Oh, good, good. It was a fun one, wasn't it? Wait, what branch am I in here? Um, this is upstream from the website branch, right? Okay. Place some docs. I'm just gonna close this and open up here. Have you noticed a recent drop of temperature about your jaw? Yes, my beard got away. My Advent beard that is growing. I was giving myself a beard trim, and I nicked a little bit too much off in the wrong spot, and I was like, it's gonna be uneven. Let me just shave the whole thing off. I'll do this about once a year. It's weird for me. Okay. Let's look in here. We don't care about that. 2023 puzzles, day 17. Okay. So this has some errata. Oh, I was hoping to have that code from the other file too. I kind of hate that they have this in different branches, but wait, it is a subtree now, right? Um, I'll just look through this bit by bit. Okay, so we have the state. That code all looks good. Here, we don't need this line. Or these lines here. Simplify that a bit. Do version 2. Yes, that is right. Lost a little bit of dead weight. This wouldn't actually work here. We have to say of visiting. Um, I hope this is mostly correct. I know there's like a typo in here. Oh, you know what? I know where I could see. The diffs are back in here somewhere. Okay, val min heat loss. This right here. And I'm gonna call it min heat loss. Oh wait, no. This doesn't even need to be a val. We can just make it direct. And this min heat map, I'll just be more verbose. We'll call it min heat loss. Um, Ordering by min heat loss. Oh, hold on. This isn't even the right. This isn't even the right thing. We want to do this inside of here, the article. Hey, Mr. Sanderson, 2.20. I like you too. Maybe. Shouldn't jump in too quickly on that. Any loss of visiting. Cool. Let's give that. I think there needs to be a new line here. There we go. Okay, same kind of edits here to the state. Yeah, that's state simplified. Mm, Okay, I think this mostly looks good. Let me look at these diffs I'd made. So we simplify these, okay. Volume and heat loss when we set it. That's a syntax error right here. Oh, no, we define it and then we set it. Cool. Oh, and we have to do s dot pause. Heat loss of s dot pause. Whoops, not in there, in here. Okay, heat loss of s dot pause. What else do we call that function? Okay, that's about it. Again, this is the wrong file. Here we go. And I'm gonna run this and take a look at how the article reads. I suppose I could add my name to this, which others do. So let's say day 02. Yeah, by ats2 squared. Okay. Um, now, let's just, oh wait, we have to go up and make sure we'll do it on the right side here. We'll regenerate the docs. And yarn start. Oh, a raid already. Welcome. Thank you for the raid. Try catch TTV. So, tonight we are doing advent code. I don't know how many of you are familiar, but problem 21 drops at midnight, so in half an hour Eastern time over here. And right now I was writing an article for day 17, and I'm just going to proofread that. So if you're familiar with the problem, maybe you can help me out. Is that vodka? I wish that'd be pretty wild for admin code right now. Just water. Okay, so this article is 2023, day 17. Yeah, so we'll solve this using Dijkstra's algorithm. Basic summary there. I don't want to read every bit. Hydrohomies, that's right. Okay, so first I introduced just modeling bits that we might need, direction and point, and some convenience methods. So that seems okay. And then I show the parsing code, that's fine, and then more convenience methods. So getting the heat loss at a specific point and checking if a specific point is in bounds. And yeah. Now our search state here, interesting highlighting here, but it's basically point, direction, and a streak in that direction. And then we have our three transformation functions. We can turn left and move forward, or just move forward, or turn right. I go over the method signature of our search, which will take a state to a list of states, a next function as a parameter. That's because this will vary between parts 1 and 2. And then inside the search, there is these are just the basic elements needed for implementing Dijkstra. We have our priority queue. We have our map of min costs. And then our visiting variable, we just initialize everything. And then the search itself here is a while loop. From the state, from the state, we use our next function that we had passed in, get more states, make sure it's not already in the min heat loss map, because once something goes in there, it's already coming from a min heat loss position. So the first time we see a state, it's going to be minimum. And then we record that minimum, and then we enqueue each of those states to be visited next. And then we dequeue from the queue, and our answer is right here. So at the bottom, I wrote a bit on part 1 and part 2. This is the only thing that's different. So we have our three possible directions, and then we make a filter, just making sure that streak stays less than or equal to 3. Checking inbounds as well. Pretty straightforward. Part 2, that streak becomes less than or equal to 10. But if our streak is less than 4, then our only option is to go straight. And this is the final code. I'm just going to browse over that and make sure there aren't any glaring errors. Okay, there are a few issues. Some refactors didn't get through there. I think we want this one here. Okay, so we'll go to where the full code is. Give me a sec here. All right, is this the full code? Yes. Our helper methods, and then our state transformations. We don't need this line at all. That's dead code. Again, this we can place down here. And this all looks good to me. Hello from Russia. Well, welcome. Welcome to the northeast of the United States. Okay. This all seems good. This here is a typo. We just set the value. We're not assigning anything. And there we go. I don't like that rule. This is fine. It has an issue with this. Duplicate. Oh. Okay, we'll call it run part 1 and run part 2, sure. Okay, so a few more edits, and let's try that again. I should have reviewed each of those edits. Oh well. And we're gonna regenerate those docs so that the web page reloads. Oh, I don't exactly know how this run part works. So that's not loading. But looks like our changes made it through. Okay, we're gonna look at an example from another article. So I don't write all of these articles. These are written by different people every day. And I mean, I guess that's it. Sure. Okay, so I can check the pull request, but I think I'm done here. Um, this one here. Okay, add an article for day 17 of 2023. I'm gonna edit this comment here. Strike through that bit. What's the syntax for strike through? It's just a couple of those. Okay, we are good to go then. So, how many of you are actually doing advent of code? Because if you are, you should join this leaderboard here, which I'm about to pull up. This is my private leaderboard. 10,000 people finally made it through part 2 yesterday. Yesterday was a gnarly one. Okay, I've dropped down to 6 here, but I'm very close to retaking 5th. I don't think taking 4th is going to happen this year. The enthusiasm died down. Died soon. Well, we are 20 minutes away from the problem dropping. So there's not much going on right now except factoring and warming up a little. Hold on, let me just fix something on my panels here. Oh well, I seem to have lost some of my information. Um, Great. So that was day 17. Uh, day day 19 was another hard. We've had a few tougher ones lately that people have given up on. Um, yeah, I eventually got this working. The final search is actually pretty nice. Um, this here's the Scala Center leaderboard. I'm 6 points behind, and I have a shot at taking back first today, but we'll see. How has this been going? So this was day 20 yesterday, and as you can see, a lot of very late part twos. Some people haven't finished quite yet. um, no one's over 90% anymore. You've had a few people who started late. Javadoc MD over here. as well as Merlinorg, who are very fast, and they've been taking a lot of first places, but after like day 10 or something. See some of these climbs. Um, let's see how they're doing. So we were looking for Merlinorg and Java.md. Started from the very back, and now they are up here. Honestly, I wouldn't be surprised if if one of them gets to third place by the end. How big is the gap? Okay, that might be tough. That might be tough. Um, okay, so as part of day 19, this is the one with the ranges. Yeah, I had some stuff from here I want to add to my library that I use for admin of code. Um, and honestly, I think from day 18 as well. Let's look back at that. Okay, this was the one with a very large area whose the very large perimeter whose area we needed to calculate. Mm. I think I potentially added some new stuff from this. My approach here had been what go to the right here somewhere. I can't zoom out. There we go. Now I'm zoomed out way too far. Okay, here we go. So this, while I was going north, I would add the areas to the right, and while I was going down, south, I would subtract the areas to the right. And that works for the most part. But then you have all these edge cases where, let's say, like right here, um, mm, right here, you move north, then east, and north, then you're adding duplicate, right? This line here between these two gets added duplicate. So I thought that this would be a simple approach when I think about just the north and south. But east and west, you have to handle these 8 different edge cases. The green and red shows what needs to be added back or subtracted. And that's why there's this big match over here. But it works. I think one of the things I wanted to do was be able to take the intersection of several intervals. Yeah, or the union of several intervals. So it would look something like this. Let's see. Okay, so those intervals, we could fold left. I don't like this autocomplete. I'm gonna edit that bit. Mm, so this is diffing against multiple intervals. So we start with just this. I'm gonna have to write tests for this. So we have several disjoint bits of these intervals. And for each of these, we just diff out n. I guess our n being a piece of these intervals. So we start with just this, and we diff everything out against this. I think I'd rather diff this out of everything. So it would be something like intervals dot lat map, and then you subtract this from each of them, and then we just add this back by consing it like that. And let's see, similarly for, well, is that the right type? This intervals, this is a to list. Okay, and then similarly for unions here. um, I think we need to diff this out of all of those. Oh, hold on. This here, this would be the union. This is the code you want to write for union. Okay, so this onto like diff this from those intervals. Okay, that should work. Let's write a test for it. Hmm. Where are our interval tests? We have some intersections. Let's do a multi-diff. Oh, hold on. This isn't quite right. I suppose we're subtracting all of those intervals from this one. Yeah, so something more like what we had originally is a correct answer. So this only goes down here. And for here, so we are subtracting all of these intervals from this. Each of those. Okay, so we fold left. And if there are none of them, if there are no intervals, then we just end up with this, right? And then here we have one of our disjoint pieces and another interval that needs to be diffed out against all of them. Um, yeah, like it doesn't really need to. We are rediffing against things that we don't need to rediff in this case, right? Because this is the accumulation, it would include whatever we just um, diffed out. It include the other intervals that we diffed out, and those should already be disjoint. So I won't quite use that. That's gonna be less efficient. What we could do is intervals.map, and for each of those intervals, we subtract. I don't know. We subtract this one. If this, and then now that is still a disjoint set. Oh no. We need to subtract from this. So this dot diff. Okay. And that potentially returns a list of intervals. Um, mhm. Well, okay, there can be multiple intervals. So let's think about this. Say we have something really big, 1 to 20, right? And what we're subtracting out is, say, -2 to 2, and then 8 to 12, sure, and then 18 to 22. Um, so when we diff this against this, we're going to get, what, like 3 to 20? And I guess others can still diff against that. I think we do actually want to fold left. Yeah, we want everything to have the opportunity to diff against the original, and this disjoint is just basically the original, but potentially broken up into smaller sets, right? Like in the case when we diff this out too, then we get 3 to 7, and then 13 to 20. And now we're diffing this one out, and it'll only hit one of them, but that's fine. I'll leave that up because that's what I want to turn into tests. Now, one important thing I need to be able to do. So we're taking unions, and then we start working with like lists of intervals. So we need to be able to take the union of two lists of intervals. So it looks something more like this, and it should be defined elsewhere. It's not going to be a method on a single piece. So let's add it in here. Def union all. Let's say there's a left, and it's a list of intervals. And then a right, which is another list of interval. And an interesting way to do it, you could do a recursive match. But we could also write something like these here, and we could take advantage of this thing that we've written. So when we're doing this, we're taking like this and folding left on it. And for each of those, we are doing this diff function. I think that's what we want to write here. So left, that fold left with right. And then there's an ACK and an N accumulator. And then we just do N onto, well, actually, N dot union with the accumulator. That should do it. And this will definitely want to have tested. So we'll give this an N type. Oh, I remember one of the things I need to do. My area type. And this came up in day 18. My area type here only works on ints. And if these areas get really large, then that will start to be problematic. So I modified part of it. Like I made my size calculation here, take an integral type, so that it converts to that type first. That's just like a quick hacky workaround. Wait, where is it? Um, Interesting. Size is already defined as well. No, no, no. This isn't even the right worksheet. Okay, but we can fix that. So to do test this. Oh, this is gonna be just a single list of interval over n. This can just be a one-liner. Okay, class area. Mm, okay, right now it's based on ranges. I'm still not sure that I want to make this based on my own interval type instead of the range, but I can at least use like an integral range. And I could add a constructor for this range type. Yeah. Like one thing I would need to do for my own interval type is make it possible to have an empty interval. I don't have that. Interestingly, it does use numeric range in here. Okay, we'll change area for now to use a numeric range. In fact, I'll move this import up here. So area over some n, integral type, and then it's going to be numeric range over that type. And this might break some of my code elsewhere unless I add a constructor. So we'll add a constructor for ranges. Def apply x range, and yeah, we just convert to numeric ranges. Everything should keep working except maybe the occasional like missing type parameter. Yeah, there'll be a lot of missing type parameters. Um, so a lot of this still just works. These would work fine if I just deleted them. Because the type can be inferred. But code that uses this will need to have that type parameter. Or just define type to be int. So this is over n, option of area of n. If against another area, just have the same integral type. Maybe. For now, that'll be required. Oh, and you know what? We are out of time. Okay. Day 19, let's just open that up. And we're going to save this as day 21. And let's pull up admin code. I have to stash my changes. Oops. I hope this is running. Yeah, it seems to be running. Okay. So day 21. And it has dropped. Let's take a look at it. Okay, another grid problem. Cool. So he wants to know which garden plots he can reach with exactly his remaining steps, 64 steps. He gives you an up-to-date map. So we have a start, garden plots and rocks. Okay, so are there other things? Um, you can take one step north, south, east, or west, but onto tiles that are garden plots. Um, right. So you just this is just a flood fill, yeah? Um, Interesting. What's going on here? So you started in this little corner here. So you could go back. You could go here, south, or you could have kept going north. Okay, this is the random walk problem. Okay, use to reach any of 16 garden plots. Actually needs to take 64 steps. Needs hit. Okay, so there's a parity issue here, right? um, and in 64 steps, we need to make sure these are sets so that we are not like backtracking. Well, we need to backtrack, but the set will the set will grow a lot. Um, so we have a grid. Get lines up to vector. To vector. Oh, and because I've been messing, I I don't know why it won't type. Okay, my keyboard might have issues. Yeah, hold on. My keyboard seems to have issues. Oh no, it's an easy problem, but okay. And then val area. We can just do area of the grid. I seem to have key binding issues right now. And is this gonna run? Because I was just editing area. Oh, I didn't give myself time. Can we stash this? I feel like that's dangerous. Um, Numeric range is not a member of. Crap. Okay, for now it's still working with the old code. Okay, so we have an area. And then we have a search. We have a starting position. Let's see, val s. This is gonna be a point. So it's gonna be area dot points iterator dot find equals s dot get. There we go. And then we're gonna do like an iterator dot unfold of sets. So visit last would be would start with set dot empty, and then we'd have like the current step. So set dot empty of point, and then set of just the start. And then we have what is it? Two variables here, which is going to be this case. Previous and then current. This isn't exactly correct code. So we're going to flat map, make sure the area still contains it, area.contains, and we want all the rocks. So we're going to diff against rocks. So let's define rocks. Okay, it knows. No, this isn't actually quite correct. This should be grid. Yeah. Grid P would return a character, right? Area contains is not a member of area because area is not compiling right now. Um, I'm gonna have to like just define my own inbounds. Def inbounds. Yeah, just do that. Val x range equals grid.head indices val I range equals grid.indices. Exactly. P point, and then we just say um, x range contains p.x, y range contains p.y. I'm gonna rename this range capitalized properly. Okay, so we're just gonna current flat map adjacent point that adjacent not filter inbounds diff against rocks. Yeah, and then diff against the previous one. Uh, and we'll do this option that when next is not empty, then we have new state and we are returning. What are we returning? Let's return current. So at index 0, we have just a current. And then our next state is going to be the current becomes the previous, and next becomes the new current. Now, steps. And then let's make this lazy list. And then, oh, we shouldn't diff against the previous because we want to be able to go backwards. Yeah, let's take a look at that. So steps at 0 should be a set of points. Oh, flat map. So current set points, flat map adjacent. Okay, so we start with just that point. Then we have 4 points. We are diffing against rocks, right? Okay, so val ends 1 equals steps 64 dot size 3758. Okay, very easy. 3758. 581. Excellent. I like that rank. The Elfson he realizes his mistake. He was reading from a list of his favorite numbers. They're both perfect squares and perfect cubes, not his step counter. The actual number of steps he needs to get today is much larger. The map repeats indefinitely in every direction. That we can handle. We can't handle this with just straight up iteration, so we'll need to be a lot smarter about this. So this is 9 of the maps tiled. 9 of the original maps. Excuse me. We handle a set of that size. 16 million elements. That's after 5,000 steps. Hmm. So we need, so we need something a bit smarter then. Think about this. I'm curious how many people have not even 1,000 people have solved. Oh, not a single person has solved part one. Wow, hard one then. So we can take our time and think about this. Um, I might need to look up some math. So for one, like, we can figure out where we first enter the grid, where we first go out of bounds. And like if we go out of bounds here, then what we could do is like given the grid, we could start from there. Oh, but we might enter it from multiple positions at once, right? And then we might enter other positions later. So even if we started, like, let's say we first entered it here, we can't just calculate, like, how does this fill up when we enter from there? Because, like, 5 steps later, we might be entering from down here. Um, but I don't know. Maybe we see some amount of repetition eventually. I could make a grid like this and test. In fact, let's do that. We're going to draw this, and we're going to use that as an example. Um, Day 21, a-21.text 2020. Save this first as example 2. And now we have our 9 grid. And let's draw some of these. So for the first part, they went like 12 steps or something like that. Okay, so let's do a def show. So given a number of steps, we're going to do like a print line of area dot draw. And at start, we show the S, maybe. I don't think we care about the start. First, we need to actually use the N. So val reachable equals depths N. Okay. Um, so if reachable, E, then we draw an O. And if rocks P, then we draw that. Otherwise, we just draw a normal garden plot. So we can show 16. Let's put this all down below. This is our new exploration. So a few stages. So 18, let's show 20. I know there's like a general math problem for like wandering around like what's reachable on every number. And maybe we could take some inspiration from that and take the rock patterns and apply to it. I'm not sure. Let's show 64 for kicks and giggles. Okay, so we'll copy this output and view it in the Scratch file. Okay, it's going to be a growing diamond. So each step, interesting that there seems to be, are you seeing this other diamond around it? Did I draw this right? Oh no, this is still for part one. I haven't actually changed the input. Not that it matters. So we just calculate the number of rocks inside of this area. Yeah, okay, I got it, I've got it. Um, 2 people have finished? Only 2 people have finished? It can't be that easy. I don't believe this. Okay, well, let's do the math. Let's do the math. Uh, we want an empty grid. So let's open day 21. 2023.text. What are we gonna do here? I think we want a new search. Let's just use that. Of day 21. Okay, so steps, no rocks. That's what we'll call this. We're just gonna copy this and use this to help us do some math. I don't know what's wrong with my cursor, my keyboard. I'm having issues with that keyboard. We're just gonna go to my laptop keyboard over here. Is that so? Well, thank you. So val steps, we'll call it steps, no rocks. And we want to count and look for that pattern. um, Look at the area as contained, and then we need to search inside that area and calculate how many rocks would be in that area. So steps, no rocks. Let's do this, like 1 to 10. And we're just gonna do like a for each dot for each. Print line. What's it gonna be? Steps, no rocks dot size. Yeah. For each n. Here we go. 4, 7, 16. Wait, that seems weird. 4. And then, oh, I guess we only want the even numbers. We don't care about odd numbers. Because now you have the one in the center, and then you have 1, 2, 3. You know what? Let's just draw. Let's just show each of those. Show n. Okay, copy worksheet output, go back to Scratch. And take a look at this. And here we're completely overriding any rocks we see. The issue here, let's make this separate. I want to see where that 7 came from, I guess. Oh, in fact, let's just show that. We'll do for 1 to 4, or 0 to 4. Yeah. Okay. 4, 7, 16. So the first step, I need to be doing this on a smaller grid. So this is the first step. And then on the next step, are there indeed 7? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, it would be 9. Just square numbers. Yeah. Oh, the step no rocks, I forgot to comment out no rocks. Now this, let's take this out. I just want to see this. Yeah. Okay. Well, diamonds. And what we could do is have a function. Will it be in that diamond? Will a location be in that diamond? And then for each possible rock location, like how far out can you go? How many steps do they take? Oh, and it is an odd number. Okay. Well, total reachable. Right, this is gonna be um or depth. Given n is going to be n plus 1 squared. And if he's taking that many steps, that squared, that's going to be a huge number. That's going to be a long. No, we're not going to use recursion here. Oh, are you talking about this code here? So this is essentially my part 1 code. This is an unfold, which is shorthand for a recursive pattern you might do. So this is recursive, except I'm not actually calling myself. What an unfold does, the left side's arrow here is what's returned, and the right side is a new state that gets called in the next iteration with this function that you pass to it, right? So it takes a function as an argument that tells you how to recurse. So we're going to take that times itself. I just want to see, oh wait, those have to be longs. So that's going to contain, if we're if we're checking rocks, I think we need to calculate how many full grids that contains, and then we need to handle like the edge boundary cases. And basically, for each of those edge boundary cases, how many would there be? Like, what's area dot size? Oh wait, we don't want the full size of it. Also, you have to say like long or something. Area dot width and area dot height. And what are we showing here? I don't think we need to show these anymore. We're gonna do n dot too long. N dot too long plus 1. Okay. Right, this should be the same. Steps, no rocks, 10 dot size, and then total reachable 10. Should be the same. Cool. So in 10 steps, those are all the things that are even candidates. And we have to subtract how many blocks would be in. Um, so if we do something that's just much larger, so if area width and area dot height is that, we're still using the full example. Yeah. Um, it's 131. How many steps can you take total? S dot dist to area dot top right, for example. Is S dead in the center? Oh, this is the start. Manhattan distance 130. Out left. Okay, it's 130 for all of them. I'm assuming. Yes, because it is a square. Okay, so we do at least 130. And then count how many would be in there. Our thing is odd, so we should do an odd number of steps. Val, rocks, subtracted. So it's gonna be like rocks dot count. And what's it gonna be like steps? Let's do 151. Val covering, or we'll say this is covered. So we have a diamond that grows out and has covered everything, and rocks dot count covered. I don't know what's the hold up here. Oh, we actually have to, that's not going to print anything there. It seems my worksheet is just not updating. Okay. Worksheets sometimes still out, and I don't know why. But basically, we would take this number. What number? Total reachable. So total reachable for dist, val max dist. Let's just define that in here. I'd put it up above. Okay. Max steps. Total reachable for the max steps. And this is the number we'd be subtracting from. And let's see, we should take the width. So where is start? Start is at 65, 65, right? You know what? I'm just going to restart my worksheet. And you know what? Let's pull out the whiteboard. Well, actually, I don't need to pull out the whiteboard. I think I know what I'm doing. Let's wait for this to compute. Think. Okay, so I wonder if it will compile appropriately if we take like modulo. So let's pull out a whiteboard to think about that. So where I'm gonna go, oh, just go down here. And let's draw a sample graph. So let's say we are tiling like a square of 9, right? And we go out. You know what? I already have squares here. I'm just going to zoom in. Well, no, that won't work. Okay, let's draw this out. Just, hi, Dafka. How are you? Well, everything overlapping with a diamond. Let's say we have a diamond starting here, right? And we are like in the very center. I should draw this in another color. Um, but here, so here, this whole grid is taken, but here, there are 1, 2, 3, 4, 5 points outside. And then here, there are also 1, 2, there are 8 points, right? So if we keep drawing this line here, it's gonna be the same pattern. So 1, 2, 3, and for here, there's gonna be nothing. And eventually we can get another 1, 2, 3. Not in that point, it's gonna be here. And were this diamond bigger, would it be the same pattern over and over again? Well, these are squares, right? So if you have, now that we know what that sort of looks like, let's say we have a square of size, what's ours? 130. So let's say we have 4, because our width, oh, my worksheet's still not running. I don't know why. I'm doing Advent of Code, day 21. You can see the puzzle on adventofcode.com. And I'm racing to finish today's problem. So part 2, basically, you want to count the number of points that you can reach by just walking in any direction except there are rocks in your way. That's an easy enough problem, but they've made it so that you can walk many, many steps away. So it's harder to calculate because you have to figure out how many rocks are all in your way. So this here is like the repeating grid of rocks. There's a bunch of rocks in there. And for the inside pieces, for the grids that are inside, this is easy enough to calculate how many rocks we have to remove from our total number of steps. But for the outside pieces, we lose parts of the grids that don't end up in there. And there are too many to, I guess I could calculate copies of grids shifted over. There might be too many. So I'm trying to solve this with just some math. Okay, so oh, oh, you can draw clean lines in here. I don't know how that was done. So if we have something like this going on, and say, we are removing this point here, 1, is always going to follow the same pattern. So we're removing that. And then in this next square, 1, 2, 3, and then 1, 1, 2, 3. I think it's always going to follow the same pattern. Oh, you know what? These squares, I can fold them off onto each other, right? So half of them. Mm, wait, hold on. Maybe not quite. Let's think. So this is square missing one. This is square missing all of those others. Um, this gets kept in. So this square, we don't consider this portion of the square. And I think we need to do this for each corner. I think we just take length out modulo some number of square sizes. Modulo the number of steps to the corner in each of these. Or modulo the number of steps to the right and left sides. I'm not quite sure yet. But we can get what that square looks like, and then we can calculate how many of those squares there are. Okay, yeah. And it seems like people are struggling with this one. They're only 10 in. I think I know what I need to do to solve this. Could I actually leaderboard today? Okay, this is running again. Little reachable is that, so we need to subtract some multiple of, wait, rocks subtracted. Why is this 0? Rocks.count covered. Is covered. Let's look at rocks. How's that defined here? Yeah, this has a size. And this is a set of points at 151 steps, and none of them rocks that intersect covered that size. Oh, okay. So 151 steps, you can't go back to the start. Steps 151. Oh. Well, no, it's a continually like growing thing. Um, okay, rocks dot. Is this like an iterator or something? Or it can only be used once? 151. Let's try this with a few other numbers. Like 64. Point to Boolean and steps that contains, right? Oh, wait. The dot contains is in the wrong part. It needs to come after the set. Okay, rocks is a set of points. Rocks does it contain start? That should be false. But it should contain starts dot east. I'm wasting time here. What's our input we're using? Day 21 dot Text. That's the first start spot. Oh, okay. Those don't actually. Let's go south and then east. Start dot south dot east. So that should be true, right? So if you looked at steps, that was 2 steps away. Rocks dot count steps 2. Um, but hold on. Steps 2 dot contains start dot south dot east, right? Doesn't contain start dot south dot east. What does it contain? Steps 2. Oh, hold on. Steps is the full thing. Of course. Steps doesn't hit rock points. We don't want steps. We want steps, no rocks. So rocks that count. Steps, no rocks. 151. Okay, okay. 1003. Well, rock subtracted. We'll just do 1003. We'll hard code this. Steps, no. We can comment that out. I want to copy this. Copy worksheet output. Unable to export the worksheet. What's going on here? It's valuing the worksheet just fine. What's going on? Point that Scala still has issues. I shouldn't have started refactoring that. I guess I could git stash it. I don't know if it will still compile if I do that. You know what? Let's do it. Let's do it. Dash. Numeric range. There's all this other stuff. This move. Guess what gets stashed? Let's just stash all the differences that we were working on. So this bit here. This bit will keep union all. That's fine. In fact, here, the only thing we want to stash is the stuff we were changing in area. So on stage that. Or the stuff we're changing, yeah, exactly, in the area. Into cool. Here it is. Okay. Dash this. We can keep that. We'll stash this bit. Keep that. Well, you know what? Let's stash this bit too. Because those convert to area n. I think that's all we need to do. Okay, z dash the index area takes enter numeric or control types Okay, back here. Point.scala. Is this back to compiling? I think it's happy again. Okay. Don't develop in a messy repo. Anyway, we're copying the worksheet output because I just want to have that hard-coded. Scratch here. So this is our now to subtract from yeah. And then val grids inside covered area. And how do we compute? So all the grids that are fully inside. Well, so we start, where's our start? We start at 65. All the way to the right is 130. The center doesn't exactly align with the center of our thing. It'd be nice if I could shift my area. But this basically goes from 0 to 130 along each. And we can expand the same number of directions in each. So we can go 65 right, and we can go 65 north. So there's 130, and then we keep adding 130, or 131 rather, as we go across. So we can subtract many 131s. Yeah, 130 to the right, 130 north. Subtract as many 131s as possible. Do we take max steps mod 131? Mod area.width, area.width. 65. Okay, what does that tell me? And then max steps divided by area.width. So this is telling me that to the right, we have 20,000 of these that fit fully. Well, okay, there's another 65 afterwards. So if we go, so we had to subtract how many steps we would take first. So if we take a look, max steps minus the distance to the corner minus start.disk to area.top right. And then from there, we see how many times 131 fits in. Excuse me. Odd area.width. 66. So 66. Oh, wait. 66 is the leftover going that way. Cool. But what you want is the number of times a grid fits inside. So we have 200,000, that many to the right, and how many to the left? Area.bot left divided by area.width. So that many grids to the left and that many grids to the right. So 202, 299 times 2 I mean, use this to calculate how many grids times 2 plus 1, the grid in the center. Can we get a formula for this? For diamond, let's say, okay, we have a diamond. Is there like a stair step pattern we can take here? I guess we could multiply. So this is like the 2000 number we were seeing. Oh, we could subtract. Okay, so each of these has like complement, right? So if we divide this, oh no, not quite that way. We'll see that. Let's do it this way. So we can divide into that. Does that work generically across the board? So there's still the 1 in the middle. That would still work for larger things. So this number times the same number times itself plus 1, and then divide by 2. And then we multiply that by 4. Okay, so we have 2000, this number here, times that same number plus 1. And you know what? I feel like there's a way to factor this. Is there a way to, oh, whatever. And then divide by 2. Well, hold on. Is that an odd number? That should be an even number. Yeah, okay. So divide by 2, and then times 4, and then plus 1 to that whole thing for the 1 in the center. Okay, so that is 818501745. Wait, you know what? We're not gonna risk that. We're just gonna copy works. Or you know what? We're programmers. That's a variable. Val grids covered. Okay. And rocks subtracted per grid. So now we have rocks subtracted. We'll do 2 long times grids covered. And then we need to know the stair step grids. So what would that look like? So this tells us how much is left over to walk to the right from. I mean, if we just did we're so close, we're so close. So that's how many steps we have left after we walk to the top right and then keep walking over 131 at a time. Okay. So if you can reach, I guess after one more step, or two more steps, we could get into the corner of one of these, and we could just do 64 from the corner, bot left. Right? Let's draw out that right side edge case. So we have a square that we reach. And from here, we have 65. We reach this step here, and then we have 65, 66 steps. It's like from inside this corner. Now this is 65 more, which is saying halfway in, and we have this thing going on. So we need to calculate this for each of the four sides. And I think the way to do that would just to be a take right side thing, go from the center here and calculate how many steps you'd go out. And then we have two more cases. I want to check the leaderboard again because this is 39. Okay, I'm not going to leaderboard, but I'm going to be in the low hundreds for sure. So there's this thing going on, and then this thing going on. And those will just repeat over and over again. So we need to calculate how many of these blocks of 2 there are. And we can calculate the bottom left of that, the center left, and the bottom right. It's all going to be symmetric. We need to know how many steps are left. So if at this point there are 66 steps, where is it? So there are 66 steps. Max steps area, mod area dot width. A lot of 131s. Now we need to subtract the distance. Okay, 60. So we calculate 65 from the bottom, right? From the bottom left corner. And for here, we get steps back. So we are, let's just do it properly here. Start.this to start.copy the x equals area.right mod area.width. And let me make sure I'm thinking about this properly in terms of them. So that is, we subtract the steps we take, and then how many 131s can you get? So we walk to the top right, and after a bunch of 131s, we're still on the top right. So this would be 66 minus 2 to get into that corner, actually. Two steps to get into that corner. So this is actually 64. That. So this is 64 here. And here, we have 0 steps available. I guess we reach all the way over here. So we could go back minus 131 to end up here. So we start on the left side with 130 remaining. Right. Minus 131. Step into it. That's our new start. 31 remaining. Okay, so let's say we need a new steps function. Def steps. Where is it? Or val steps. We need start as parameter. Just make a new function. We don't want to break any of the code and have to fix it. Steps from start point, and nothing else changes. So we decided 130. This is 130 remaining from here. And here we have 65 minus 131. Or like we get plus 131 back, or 66. 66. We can just use a 64. 64 minus 131, or plus 131. 64 plus 131 is 195. So we have 195 here. Okay, let's calculate each of those. And it's going to be steps from start.copy x equals area.write dot take 64, take 130, or rather just index into 130. 130 steps in, dot size. Great. And then from bot left, area.bot left, you have 195. Oh, and we have to actually calculate like what we're subtracting. So we're going to count rocks. Count. We'll do a test here. So that size, that count, rocks. Oh yes, the rocks will be 0. We need like steps from empty, because we're getting stuff that we need to subtract from the larger thing. So def steps from, we're going to do a no rocks version of this. Steps from no rocks. Comment that out. No. You know what? We could leave this as a test. So we'll copy those over. Steps from no rocks. And some of this math should add up, right? So 6468 minus 766 should equal 5700, but that's wrong. Also, I meant to do area.left. $702. Why is there an off by 2 there? It's very close. Okay, we're starting from the left, and we're able to move 130. This is how many places are reachable. But what we want is the number of rocks that are in this place. Let's just do a check steps from, or you know what? Let's do steps 64 dot size steps no rock 64 dot size, and then steps no rocks dot count rocks. I should add up. So 4225 minus 467 should be 3758. Okay, it works properly there. I think I'm going to trust my steps from. Oh, I wonder if these alternate like odd and even. Mm. Okay, we start at 65, 65. Right. And we get to the right edge after 65 steps. And at 66, we're back at even. So, wait, the whole width of the area is odd though. So these are going to be alternating. Right, the whole width of the area is odd. So it's not quite. What were we subtracting? To subtract from, how did we calculate this? The number of grids covered. We should divide this by 2. Half of them will be one type, half of them will be another. And then half of them will match the parity of the first one. Okay. So where was that number we'd gotten, this 202? Let me just like try covering. Let me just try covering. Wait, 1003. Wait, that's the number we're using. So let's do this. Let's do 150. So the first one is going to be odd. The odd one. So this is odd rec subtracted. Odd box sub. And then val even rock sub equals 968. Okay. Let's look for rock sub is used. Rock sub. Yeah. So this isn't quite right. We have an odd and an even version. So we're gonna do like times 2 plus 1 is odd. Is odd. Okay. Great. 202, where did it come from? 22900. This one right here. Yeah, that's my calculation of how many grids 0 to the right more. Are these different? Now grids to left. You can just comment that out and put the inline version here. Max grids away. Max grids away is what we'll call it. I'm updating a comment. So that's this. So we have even and odd. So odd rocks sub times odd grids covered. And even rocks sub. Even covered? Yeah. Guess it's cool meaning it. Even grids covered. And then I'm still not sure about this whole thing here. I guess the steps from is fine. I think I believe this more. Count rocks. This is an even number of steps. I think, yeah, yeah, it doesn't matter if we've had an even or odd so far. Because we're starting that at 0. No rocks. I don't know why this differs. Should add up. Okay, let's look at more cases. We want to do this for area.right too. Wait, when you start from area.right, okay, this differs. And let's do 6, 4, 6, 8. Wait, why is this? There's some from the rocks. This should be the same in both cases. Cool. So 6, 4, 6, 8 minus. Okay, maybe I should just be adding. I should just be adding. I shouldn't be subtracting from the total. Subtracting from the total feels better though. Minus 766. Oh wait, up here this should be 744. That's why. 744. 6468 minus 744. I mean, that's even worse now. I don't know why that would be different. But let's look at definitions. Def steps, no, steps from. Right here at every step, we're diffing You're diffing out the rocks. Oh, is it possible that something's become sort of unreachable? Ah, it is. If there are enough rocks in the way, you wouldn't get there yet. You wouldn't fill it. So let's look at my input. Day 21, 2023. Yeah, there are big blocks here. There are not too many big blocks. I think it should fill eventually. But we should do an adding based model instead of subtracting. So odd grid's covered. So instead of doing this, yeah, make something that's additive. Um, so odd covering. There's another even and odd we defined here. Even rock sub, odd rock sub. That's not what we want. How were those defined up here? Rock side count. So we just do steps, no rocks. Or we just do steps 151, that size. And this is odd covering. Even covering. Steps 150 size, not too long. And here, just have odd covering, even covering. Okay, and then now we have the right side, which is repeated above here. Step from area.right dot size. This is perfect. So this is all what we're adding. And we do that for each of the cardinal directions. X equals area.left. And then y equals area.top. And then y equals area.bot. Those should not all be 157. Oh, that is why. Why we had an issue. Wait, this is diffing rocks. Oh no, they aren't all different. Okay, cool, cool, cool. And then we have the two right corners. We have to calculate how many of those there are. I think it's as many as, let's look at our grid. So there are sets of two right corners. We'll draw them in the green here. So all of these get affected. Here's a set of two. Here's a set of two. It's just the width. Whatever that width thing we calculated before was. Okay. Width. This thing. Times two things added. And those two things being nope, we'll get the names. So val top right corners equals two things added together, which will be steps from something like this. $64 and $195. So we just start from the bottom left. Oh, yes, we start exactly. Let's area up on left. And we just add those two. Oh, we dot size each of these. Max grids away. And yeah, we multiply each of these by max grids away. Times top right corners. Now top left corners. Now bot right corners exactly. And you know what? We can copy those variable names this way. I'm pretty sure Copilot can autocomplete that, but you never know sometimes. Max grids away times these four. And that is it. We take the sum of all of this. That sum, and that's our ends too. Oh, I so hope this works on the first try. Wait, longer int. Are these not all longs? This is long. We should turn all of these. Too long. Okay. This computes, and that is our answer. Is this it? Is this it? Okay. Answer's too low. Okay. We are close though. I know we're close. This to the right is max grids away. We might be missing a little bit here. So we're missing one of the corners. This applies to And either way, you can add one or the other of them. They're still grouped into twos. Um, yeah, I've got it. I've got it. So we're just going to add the smaller ones. Oh, wait, the smaller ones are large ones. Does it matter? Hmm. So here, what we computed is above everything. So we should do the small ones. Yeah, we should do the small ones. Come on, cursor. My my dang keyboard tonight. Okay, so we add this number to that, and then you got it. Mm. Nope, nope. Copy worksheet output. Come on, copy the worksheet output. Where is it? Okay. So val adds 2. Here's my new answer, which is a little bit higher than what I'd given before. My dang cursor. It is not working. Okay. The answer is still too low. Okay. What's missing here? Hey, good morning, Blue. You completely overslept. Today's problem, I'm having fun with it. I think I'm almost there, and I'm excited about that because um, only 180 have solved it. I was watching this go up. I was thinking, oh, maybe today I leaderboard actually, but too much watching the clock. Um, okay, let's go over this. What corner bits am I missing? Uh, or maybe one of our things is slightly too small. So 130 to the right. We get all 4 of these um, right corner bits. Right, and if you're going from here, 130. Should verify these 3 numbers. Okay, so it is 65 to where have we computed these? um, what is it? The max grids away. Where's that computed? Let's look at that. Well, max grids away. Okay, it is this thing. Um, so we do it by calculating to the top right because we want to stay inside the grid as we move over. Then we divide to get max grids away. And then this is steps remaining. We're in the top right corner. We can walk 60 steps out into one of the grids that are only partially covered. So carry it out with. Yeah, we max steps, subtract away 65 steps to get to the top right. Is it 65 steps? I think it's 130. Or 65 to the right and 65 up. Yeah, 130. So we subtract that 130. Oh, our right calculation might be off. So I'm pretty sure here we have 66. We take 65 and then we have 131. We step into there and we have 130. Okay, we step into this corner and we have 64 remaining. Well, I'm off by ones on all of these. And 64 minus, wait, plus 130 to move to this spot left. 199 plus 60. Wait, hold on. Yeah. No, it's 131 to get to the left. Wait, no, 65 steps to get to center. It's 130 steps. This is not 195. So it's 65 minus 130. Right? Oh no, it's a full width. Yeah, it's plus 131. And it's 66 plus 130. So 196. And then minus 1 to go up. So that's 195. That's right. 130, 195. Okay, I'm pretty confident about those corners. Those corner numbers. Here we add both the 64 and the 195. And there are more of these, right? Always gonna be more of these. Wait, but when do these stop? There's one above. Yeah, 1, 2, 3. There's exactly one more of those. And there are grids away numbers of this. Okay, so did we calculate grids away properly? I think so. We have 130 steps from here. We'd go all the way to the edge, so that's fine. We don't have an extra piece here. Yes, I'm on part 2. And I'm almost there. This is too low for some reason. Oddrux to sub. Oh, it's not Oddrux to sub. Crap. It's stuff to add. Covered. Odd covering and even covering. Odd covering. Even covering. There it is, there it is. There's my new answer. No. The new answer hasn't computed yet. Come on. And how's odd covering calculated? this is a bit that I should have had down here. And odd rocks to sub is going to be smaller for each of those. This explains why it's smaller. Cool. Well, compute, compute, compute. I have the answer. Come on. Ah, these worksheets are killing me, man. Okay, I close it. I just restart it. Hope it runs. Okay, wait for that to compute. That's all this computation is doing. It never goes more than 130. I don't understand why my computer is struggling. This is very easy. Right, like this here. Be that. Come on, just show me the answer. I'm gonna run this in the console. Okay, it's compiling. Compiling. Root. It has compiled the entire space, not just this. Why? Okay, codeless generation, thank you. Wait, we have an out of memory error? And where? Because of what? It is evaluating the worksheet now. It's never taken that long. I don't know why it's taking that long. I changed. What? That is a much larger answer. Is it not? Copy worksheet output. Come on. It's not copy. Okay. Copy. It's my keyboard. I've been having keyboard issues tonight with my mobile one. Oh, and it's two. Okay. This is it. Looks suspiciously large. Yeesh. That's way too large. Make it try it. That has to be too large. Yeah, that's too high. Okay, what changed? So odd covering. How's odd covering times odd grids covered? Oh, wait, odd grids covered is pretty large, so that makes sense, actually. Versus the sub thing we were doing. Yeah, that makes sense. It should be a lot larger. So now I'm overcounting something. So odd covering times the odd grids covered. Odd covering is a long, odd grids covered is a long. And then the four corner bits, all at 130. And then other like chopped off corners. Yeah, that's fine. And we multiply those all by max grids away. And let's count odd grids covered and even grids covered. Right. We did that stair step thing here. So the number of grids away times the number of grids away plus 1, and divide that by 2. Right, so a single corner is like this. Oh, even grids covered is too large. That needs to be 2. So if I divide my, yes, there it is, there it is. Okay, now I've got it, now I've got it. Okay, here it is. Here it is for real this time. I know it in my bones. Oh, and I have to wait 5 minutes. Okay. Is plain wrong. But didn't tell me if it's too high or too low. And what does that mean? That means, what's this thing showing up? Oh, total max, total reachable. Yeah, whatever it is, it should be smaller than this, right? Yeah. I just want to compare this number. Okay, yeah, so this is an upper limit. That seems like a lot of points though. Look at odd covering. Odd covering, how big is that? Versus like um steps, no rocks. You know, I guess I have a function here that returns a lazy list, but I call that function again multiple times, like steps from, well, I mean, I guess I only call it 4 times. This is a simple mass deletion. Um, I mean, I've done a lot of math to do this. This here is just whatever squared, steps squared. It's the total number of steps reachable. My first idea was to subtract the edge cases and subtract like the amount of rocks per cell per like repeated grid. But instead, I'm just like this is the amount of things in a grid. So odd covering is 75. Okay, what was I gonna do this? Odd covering. Wait. Steps no rocks 151. I just want to see like the upper limit on that. Right, this should be larger than 2574. Oh wait, that size. 21 seconds is way too long. I'm recomputing too much stuff. I need to delete stuff that doesn't need to be viewed all the time. Yeah, H580. So that's lower. And what was like the odd like rocks to remove? Odd rock sub is 1000, even rock sub is 968. That makes sense. Those are each like roughly half the number of rocks in a grid, right? If we did like rocks that size. In fact, they should add up to rocks that size. Um, Even covering is defined somewhere. Even covering is 7,612. Yeah. In fact, like this whole thing could just be the number of rocks times whatever. times this thing without the one. Yeah. So there's one way to simplify that. But it should still be the same answer. Where is it? Where is it? Um, that's fine. That's fine. My odd covering, my even covering both make sense as numbers. Um, these should all be like lower numbers. Oh, you know what? We have this here. 5700, 5722. Yeah, all around that number. Each of these are around 7,000. Those numbers make sense too. Is max grids away, like off by one or something? You re-add these. We keep recomputing a lot of things that we don't really need to recompute. There's just a lot in this worksheet. It's grown a lot. Oh, there was this weird discrepancy. This could have something to do with it, right? 4225 minus 467 rocks should be 3758. That is cool. Yeah, it's probably coming from whatever's causing this discrepancy right here, because these two numbers should add up. Um, oh, what if that bottom left is a rock? Wait, hold on. Our input doesn't have rocks in the bottom left. Honestly, it shouldn't matter. Yeah, it doesn't. The whole area around it is unoccupied by rocks. So starting from the left, cutting across. What if I did a variant of this where I subtract it instead? When I'm covering, well, when I do that, it makes sense. What about when I'm just covering? Try that. So, I know, let's do 150, 150, and 150. And then maybe for good measure, we'll throw in like 151. And those should add up as well. So this is a full cover, right? So let's look at this. 968 plus 7612 equal the full thing. And 1003 plus 7547 should equal the full thing. 8580. Yeah, and it does. So why is it only wrong? What is area dot right? I guess if you take 130 steps, if you take 130 steps from the right side, then you get to the left side, right? We could do that. So like start dot copy x equals area dot right dot dist to start dot copy. Wait, it's gonna be like 131. No, it should be 130. 65 to get to center and 65 to get across again. Okay. Um. Well, currently I'm using this value. What if I use this minus this? Let's just do a variation of this. Just because the rights seem weird. Yeah, we'll make a copy down below it. Comment this out. Touch from no rocks. And then what's this thing I'm subtracting? I wonder if I reevaluates in another worksheet when I have it split. It shouldn't need to do that. They should be sharing things. This is a regression. This is a regression in metals. Because I remember asking for this bug to be fixed. Um, no rocks. Oh, such from. And when we count rocks, right? 6. If we count the rocks in that set, sure, let's do it. So give me a slightly different answer. Um, instead of dot size, not too long, we're gonna do dot count rocks dot too long. And this annoyingly gives me a slightly different answer, but it's probably the correct thing. Okay, we open up Scratch. Eight. And then val ends 2. Not the one that's commented, this one here. Okay, well, if it's anything, it's this. 5 minutes before retrying again. So that is also wrong. But like other things could be wrong for similar reasons, like all of these bot left counts. I can check this. So we compute those somewhere. I guess we compute them here. Yeah, let's compute like a few copies of it. This is just what it is. Oh, no, 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 not that, not that. Okay. Let me do this. Copy it. Steps from no rocks. I'm just testing for discrepancies here. So we're gonna do a count of rocks, not too long. And these all should be the same. Oh, I'm running a lo-fi Leah playlist. They have a bunch of covers, mostly of video game music. Um, Look at all these slightly wrong, slightly off answers. Okay, so let me do this, but I'm gonna trust the other thing, just the minus count of the rocks. What is the difference between those two? Well, the difference actually might not go in my favor because, like, what if, yeah, some just might not be reachable. Uh, yeah, I think the minus rocks is not gonna work. I'm gonna comment out this one. I think I know why it might be different. So using my normal steps from no rocks will calculate like everything that is like theoretically reachable without rocks, and then subtracting the rocks. And just subtracting the rocks should not work necessarily because there might not be a way to get past like a wall of rocks or something. So it's better to do steps from. And that explains why that would be different, right? And that explains why it's not different in the case where we're completely covering, right? Where did I do that? Like right here, right? Completely covering, those add up properly to 85, 80. Okay, so that makes sense. I'm not going to worry about that anymore. That's not where my issue is. In fact, I'm going to delete this so it doesn't screw me up. Steps from the right, steps from the left, top, steps from the bot. Are those values 130, 64, 195? Are those correct? That I can double check. Max grids away. I'm very sure that's correct. Top right corners. There's like the small top right corners and the large top right corners. We could separate those out. I guess we'd be doing less like recomputation. But 194, 195. We've looked at this repeatedly. Right, when we get to this point here, there are 66 steps remaining. In fact, the whole thing, modulo, where are all my modulos? Max steps divided by area.width. Modulo area.width. So our 202, 300 grids worth of moving right you can go. And you can take another 65 steps. Or you could take the 65 steps first. Should this be +1? Like if you take 65 steps to the right, then you have this many grids to cover, but that last grid won't be completely covered, so it should be -1, 202,299, right? That's how many we get to the right. Because we first try to go to the top right, make sure it's completely covered. 2650135. Let me make sure I actually copied that correctly. 2650135. Okay. Area dot width is 131. 5 steps go to the right side, and then we keep basically going from the left, covering of grids. I mean, let's say we subtract 65, then yeah, we cover 22, 202, 299 grids to the right, and then we move 130 steps into the last one, right? 65 to the right. There are that many grids both left, except the last one we don't count. So we subtract 131. Wait, shouldn't we subtract 131? No, we add 1 because we want to start in it. We subtract 1. Yeah. So when we get over here, there are 131 steps left. That makes sense. That's taking 131 steps would get us to the right edge of this. And we know it goes to the right edge because we did the math. There's a modulo 65. Or, we subtract that 65. What's with the 66? So we subtract 65, subtract 65. It needs to add up 130, right? And you go 65 north. You get to the edge. And 66, one more to get to 64. The 64 remaining here. And you add back 131 to go here, 195. That's fine, that's fine. Where is it? We're so close. Ah. Yeah, I can link the playlist. Sorry, I missed your message. This might link directly to a song in the playlist, but you can figure it out from there. This one tonight is not a specific playlist, it's just a shuffle of all of their music. This is late. This is plain wrong. This is also wrong. I believe that. Steps from function. I'm like pretty confident in it. Start. Part being this point here. Current flat map adjacent. Filter inbounds. Diff out the rocks. Part one done. Great. Congrats. Got 581 for part one, so I was pretty happy about that. And I might not make 1,000, top 1,000 for part two. Which is annoying because I feel like I've had the answer for a while. I'm just trying to find the missing piece of this. Okay, let's look at these step by step. This we've done repeatedly. I'm pretty confident about this. Evaluate each of these. No. Max grids away. 22299. Yeah, I just hard coded that. Um, oh. Top right corners. Let's look at that. Mm, Okay. The smaller one's the one gets repeated more often. So we've handled that. Hmm. We had the same thing going on. Brute force takes um a long time. Oh, I can't fall asleep now. I'm sure about this. I'm sure about this. Am I sure about how I'm using max grids away? Um, top right corners. Wait, top right corners is not multiplied. Oh, yeah, it is multiplied by max grids away. Cool. Here. Look at odd grids covered and even grids covered because those also use max grids away. Right. These is that value again, grids away. Grids away times grids away plus 1 divided by 2 is 1 corner. Each of those edge grids actually covered. I could test this on a smaller copy, like 9 by 9 copy. I want to. Yeah. Divide by 2. Why do I multiply by 2? I guess I multiply by 4. And then I divide by 2 because half those grids are going to be odd covered and the other half are going to be even covered. Right? We move 65 steps to the right, 66 steps to the right, and we're in another place. We move an even number. And then we move another 131 steps to the right. And I guess that also becomes, wait, are all the grids going to be odd? Everything's going to be odd. Let's try it. Hmm. Oh, these smaller grids, the odd even approach. So there's an odd number of steps between each grid. I thought, right, like only so many positions are even reachable in an even number of steps, and none of those are reachable from an odd number of steps. And I'd been thinking, okay, since the width is 131, this is going to be alternating. And that's actually not the case because it takes an even number of steps to get to start repeating, right? You take 66 over to the right, and you're in the next grid. But in the top right corners, yeah, okay, so there is some even odd thing going on. Um, for all the main grids, wait a second. Does it vary if you go up? Okay, yeah, to get into like a kitty corner grid. Ah, let's look at that. That's where my issue is somewhere. Um, so let's draw this. Okay, we draw this. We start with some square. We start in the center. It takes an even number of steps to get here. So these two always be in sync. Does it take an even number of steps to get here? 66 steps to get up here. So these two will also be in sync. So anytime you're covering any of these, well, wait, 65 steps right, 65 steps north, and then 2 more steps. Okay. So the parity is the same on all of these. Um, yep, that's exactly what's wrong. So we fix that, and we've got this. I know it for sure this time. Absolutely know it. Okay, wait for this to run. Okay, we copy this worksheet output. And look at val ends to. I really wish I had a better way to copy paste this out, but wait, isn't this the same answer I've given before? No, it's not. Oh, okay. Had I been messing with even and odd anywhere else? Um, oh, I'm not gonna make top 1000, am I? I still can. It's growing slowly. So wait 5 minutes. At 2:20, we need to submit something. Hmm. Um, these values here. right? This is just odd coverings times grids covered, right? So length times length plus 1 divided by 2. This is long. Divided by 2 and times 4 because there are 4 of them, and plus 1 for the centerpiece. So let's say odd covering. Odd covering is already long times grids covered. Mm. And steps from, like, I'm still pretty sure about these values. And I've had like a solution that I like, the rough idea of it, for over an hour at this point. And I'm just tweaking it, finding little bugs in the math, which is a frustrating feeling. I'm giving myself a little break by removing some of this duplicate stuff. Um, I don't need this anymore. I don't need any of this. Grids covered. Max grids away. We can just make this a calculation. Um, yeah, that works. I'll leave that up. It's somewhat useful. Total reachable. We're not using that approach anymore. In fact, we're not even using steps, no rocks. Yeah, we're not using either of these. Mm-hmm. You don't care about this. You do care about max step. Okay. There are the small corners and there are the big corners. I guess I can do this. Small. And then the big. Make things a little bit more explicit. Hmm. We don't even care about this anymore. We just want the odd covering. This we can just comment out. I'm sort of still partial to it. That thing happens. This thing we don't really care about anymore. This thing we don't care about anymore. Now, grids away times all plus big. And then top right corner small. Okay. Extra low corner is missing. And I'll add commas there. And we can take out all this stuff here at the bottom. And let's look at our grid again. So the small corners, there are more of them. Right, this here, this value is max grids away. The max grids away times each of these, right? What we're gonna do is just have the big be separate. Plus 1 times the small. Okay. Now we can remove these commas here from the end. We will promptly replace those commas once we copy it into here. Okay, my answer is more programmatic now, no hard coding. 223, I'm eligible to submit again. How is this? What is still computing? I don't believe that. Okay. Alligator, I think I've seen you somewhere else in another stream. Yeah, well, I'm doing math. I don't think this is. I mean, cycle finding can sort of help you. Like, if I did this on a 9x9 grid, I haven't even made like a larger grid. If I did this on a 9x9 grid, I can confirm some of my values for like the top right corner is small or something like that. Right, by taking a bunch of 131s off of, like, just modulo 131 of the max steps. Wait, we have an issue here. Long and int. Oh, hold on. Do we have things here that are int that shouldn't be? That be our issue? Max grids away is a long. Max grids away is an int. That's worrying. Just too long, that. Too long. Let's make max steps along. Yeah, why not? Divide by area dot width. Sure. I think that's what he's talking about. Okay, are all these longs now? All be longs. This is a long times a long. Okay, so this should compile now properly. That's an answer I've seen before, right? That's still this answer. So that didn't change anything. That's what I tried latest, isn't it? See. I can't see what I tried. I'm pretty sure I tried that. You just BFS'd a large number of times and looked at the deltas between times. Claim to cycle is number of elements between the last two occurrences. Oh, Zombie Chow, thanks for the raid. Welcome, welcome. Did you finish tonight's problem? I've had my solution, my basic solution, for well over an hour now. And it is like a math approach here. Basically, I calculate whatever one grid should be. I calculate how many grids there are inside of the diamond, how many full grids there are, and I multiply those, right? And then I have to handle all these edge cases. It seems like some of my edge calculation might be off, but like I first submitted for part 2 like a while ago. In fact, I think when I did, it was still not 100 people had solved it yet, or barely over 100 people had solved it. I'm struggling to figure out where my issue is. So there are these bigger corners and smaller corners. Or rather, there are two types of corners. And one type gets repeated. So in our case here, the edge the very edge goes in 130. You have these small corners, you have these big corners. And this happens as many times as there are, right? These big corners are above. This happens as many times as there are full grids to the right. So I multiply it by that. And now the small corner needs to be added back one more time because it happens one more time than the big corner. So that's this part right here. Max grids away, my number of grids away, times the big corner, and then plus 1 for the small corner, right? So that looks good. This here is the area of the right side. The number of places to hit in here. And of each side, x area dot right, x area dot left, y area dot top, y area dot bot. I do each of those. And then I have my covering. Initially I had split this into like a left and right, or I mean odd and even, because I thought there were odd and even bits. But apparently that's not the case. after more thinking, I realized, oh, it takes an even number of steps to get into the bottom left corner or the side of another piece, which is where you're going to start, either the corner or the side, which means they all have the same parity. So that's not something to worry about. In fact, I kind of wish he did make parity something to worry about because I spent time worrying about it. And that would slow other people down. Um, but alas, that is not the case. Uh, this formula seems totally fine. And we could look at our max grids away again. And like, I'm pretty sure about these. Like anyone else, did anyone else do like this kind of approach? So count 130 steps in from the left side. This should be 130, right? Because the answer, we're just moving to the right. The answer mod the width 131 is 65. It takes 65 steps to get to the right edge here. And every 131 should get you to the right edge. So where you end up here is the right edge. And going from the left edge to the right edge is 130. Happy about that. Move up 65, gets to the top left corner of this. Then to get into the bottom left corner, it's another 1. So you subtract 66 and get 64. Right? Similarly, I also just calculated this corner, how far away it is. So this is 66 from the center. So when we go into here, we have 64 steps remaining. 195. I've looked at this so many times. I'm pretty happy. I'm pretty sure width is 131. Yes. But if you start on the left edge, not outside of it, but inside of it, and take 130 steps, then you get to the right edge, right? Because, 1 plus 65 plus 65. Keep questioning me on that. If I'm wrong, let me know. In fact, you know what? I wrote that up somewhere in here. Like area dot bot left, all this stuff. Left, right, top bot. Edward, thank you for the follow. For cells where you can enter from multiple directions, did you account for that? Yes. Oh. Okay, you mean here on the very edge. On the very edge, if you're starting from here, would you actually get more? Because, yeah, you're right. All I'm calculating is if we started here, how many rocks would we get? And if there's a bit here that we can't actually get to, then we might actually get to it from the bottom. Right? That's what you're saying. That could be it. That could be it right there. Chris, did you finish? Maybe we can do this. So let's do start.copy and then x equals area.right. Right, let's and this to start.copy x equals area.left. Right, those are left and right edges. And that should be 130. Right? The rightmost point is 131. Middle is 65. Adding 65 gets you to 131. Subtracting 65 gets you to 0. And my range is 0 to 130. I mean, adding 65 gets you to 130, right? How well does a GPT method work? I haven't loaded up GPT yet, so I know. Brett, you finished, but you didn't try this method. I mean, this method seemed like it'd be very easy, right? In fact, I submitted my first attempt like an hour and a half ago. And like I didn't have to. You know what? You're probably right about this not being necessarily the same. Like this 130. Let's say if we're expanding out from here. By the time we get out here, then this is reachable. Hmm. Right, like if we can't get to the top left, I did worry about that slightly, but then I looked at the input. Um, let's take a look at the input, and it's so sparse. Okay, here, right? There's a top left one. Yada 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 yada. Like if you fill this in, would it be any different? In fact, you know what? Let's draw some of these. Let's draw some of these. I have this ready. Up here, have you ever show method? Uh, no, we need to do this in a few different ways. Okay, we're gonna copy over this bit. We'll do this a few times. So val reachable equals steps from start point being the top left. Area dot top left. And we're gonna go 64 because that's what we have in our grid. Yeah. So we can print all those maps. Now let's just do the top left, bottom left. Or you know what? We'll have a list of starts. Val starts equals list area dot top left, area dot bot left. Okay, continue this. And then start dot copy. Okay, it's knowing. Okay, it knows. So we have all of our starts. And then we can do a starts for each print line. Starts dot for each s. Then we show reachable from the start. They got all these print lines. Yeah. Oh, for each s as a parameter here. There we go. And we'll copy the worksheet output and read those maps and try to decide. Forcefully enable that, sure. I don't think it's that much of an issue. Okay. Here we go. So from the top left. Okay, so a lot here is covered, right? There's nothing that would only be reachable from nothing there is missing. From the bot left, nothing is missing. So big blocks of rocks are not being problematic here. The top right, no big blocks of rocks are being problematic. Right? You can't get more than that. And here, from the bot right. Yep, we hit that whole line. In fact, you can kind of see it in the input. There's this big clearing, isn't there? Yeah, I think that's intentional in the input. If you zoom out, can you see that, how it's faded? There's a diamond. So I think it's intentional to prevent that kind of problem. Um, and here is from the left side. Oh, we don't want 64 though. For each of those. What we actually want is 130. Um, yeah, you know what? Well, distances equals list, and we're just gonna hard code this. 64, 64, 64, 64, 130, 130, 130, 130. So we have S and we have D. Let me put D here as a parameter. What's the issue here? Wrong number of parameters expected. Wait, that's fine. Oh wait, starts zip distances. There we go. Oh, hold on. You want that to be a D. We'll cancel that. Make sure it does the right thing. Okay, look at this worksheet output. Again, I don't know why it takes so long. We're never really calculating that big a thing. And again, I guess because of those big spaces, this is not going to be too much of an issue. But I do want to verify something still. Yeah, so it hits very right edge. And thanks to that big clearing, we don't have to worry about edge cases with rocks. Cool. Okay, that's a debugging detour. Let's go back to our thing. Each of these get added once. Yeah. I think this whole formula. Go over this, right? This full formula should be correct, right? If you've been over this, max grids away times the top. That should be right. As long as these values are correct, then that should be right. Max grids away plus 1 because there are more of the small corners, right? And I wonder if it matters for the big corners. No, the big corners will also show up in that clearing. So it shouldn't matter. Hey there. So, and then we calculate each of the very corners of the diamond with the 130. So this formula, the sum of this should be correct. So I think, right? Are you convinced of that? Because if not, I can pull out the grid again and compare. But I've been over that many times. So one of these values are incorrect. Then we have an issue. We can go over how these are calculated again. We've gone too many times over these corners. So it's the 64, 95, 130. I'm pretty sure about that. I'm very sure about that. Max grids away. Maybe there's some Maybe there's some uncertainty there. Odd covering, let's look at that. Yeah, we just cover the grid with an odd number of steps. Why an odd number of steps? Because max steps is odd. Yeah. So there's odd covering. Number of grids covered. That might be wrong. But we can go over that computation again. Max grids away. Grids covered depends on max grids away. We need to make sure this is right. Has anyone already calculated this before? Like, did you see that there are 202, 299 grids to the right that you can have that are full grids? This is where like the modular arithmetic came into play. And what I do is I walk all the way to the top right corner. So it's max steps minus this. This is going to be 130. And modulo area dot width, right? I take away 131s. And what remains is 66. Right? I get the 66 for right here, that corner. In blue. I don't know if you can see that. And if that's the mod, then dividing it is the number of full grids. You can still move to the right. So we move to the top right corner of our center grid, and we move to the right 202, 299 times, and those are all the full grids. In fact, if we add 66 here, we should get this one here, this point right here. Which we could calculate, just do more math. So 130, at this point, we have nothing. Go up, negative 65, go left, 65 is center top. Yeah. So this is the same distance as this. Minus 65 to the top left corner, minus 66 to here. Right, so there's 66 remaining. That's exactly this here, right? So 66 remaining to go there. Great. And I mean, we could do, 60. How would we do this? So area dot width times 202, 299, right? That's the number of grids we can walk to the right. And before we do that, let's walk to the top right corner. That will get us to this point right here. So plus start.dis to area.top right. That gets us to this point right here. Okay. Oh, wait a second. We need a long in there. Maybe? 265.0.1365. Okay, hey, this is interesting. So if we walk to the top right, and then add area.width. That's the number of grids you can walk over. Oh, that gets us here. Yeah, that gets us here. We're still in the whole grids. And then we have to add the modulo. So we have to add 66. And let the worksheet compute. And this should go back to this value, 265.01365. 265.01365. Okay. Yeah. So I'm convinced that we have the right number of max grids away, 202, 299. Let's look at our grids covered formula. So to do that, we're looking at here. And I partitioned the grid into 4, right? There are all these pieces. This length here is grids away, max grids away. And what I do, I guess what I do is I take one of those and then I flip it over. I take the area of that and I divide by 2. So that here is this times this divided by 2, right? We'll just put parentheses to make this very clear. So length times length plus 1 divided by 2. And then we multiply by 4 because there are 4 of these L shapes. And then we add 1 for the center bit that we're missing. Okay, so that's grids covered times odd covering. And this is most of the way to the answer, right? Whatever it is, it should be larger than the 6199 ending in whatever. And this is the same as this. I haven't changed anything. 33174. Right, whatever this is, it's larger now. 619933, 619939. It's this answer here, which I've submitted and is wrong. Oh my god, where is it? Oh, I'm going crazy. So we just did grids covered. My math there seems right? No one's contesting that. Missed a bunch of chats. I'm gonna look back through here. I'm worried about getting the yes, you talked about worrying about the parity of path alignments. The path length's correct. But we talked over that. Oh, big note from Zombie Shell on completing. I missed his comment there. Okay, grids covered. We've been over this. We've been over each of these. We've been over the top corners, the big corners and the small corners, and the fact that there's one more of the small corners. We've looked at everything here. Odd covering plus times grids covered. Like, should the first not be counted? No. We could also like print line a full covering. See what that looks like. No reason to. Where's the issue? This feels straightforward, and I've gone into every one of these. Let's see where I'm falling on the leaderboard. Yeah, I'm not top 1,000 anymore for this part. At least 1,000 people have solved it. Uh, this being too high makes sense. This being too low makes sense. At this point, I'd I'd copy the wrong number for one of these up here. But that's fixed now. And I've checked over the definitions of all of these. Top right, top bot left, bot right. Let's make sure there's not like an issue. Area the top left, bot right, bot left. So we have one of each. Yeah. Bot left, top right, bot right, top left. We have each of those. Oh. And it is in fact the small corners that are repeated. Mhm. Uh, like this code doesn't seem that complicated, right? It's just that there's a lot of it. Hmm. And I don't think I'm gonna try another approach besides this one. I kind of want to make this one work. Um, but those of you that did finish part 2, what approaches did you do? I think Chris mentioned doing like a cycle detection of some sort. Oh. I could try a significantly smaller number of steps on like a 9x9 grid. Remove a bunch of 131s. Reduce my max steps. And see if this answers the same. Yeah, we can test against that. At least we'll have something to test against. So val, large grid. And we can go grid.map. So we have row to row plus row plus row. And we have widened, well, widened. And we do widened plus widened plus widened. There we go, that wasn't so hard. And let's try, where do we define max steps? Max steps. Okay, around here. Let's do, this. Large grid steps. Val, large steps. Where would the start be? I suppose we have to add 131. Yeah. Start to x equals start.x plus 131 plus grid.width, and y equals y plus start dot, or I mean start.y. plus grid dot height, right? That gets us into the center of the center one. And flat map adjacent diff rocks. I guess we have to have defined like large rocks. Um, yeah. Well, large area equals area of the large grid. Sure. Um, and then val large rocks. Do the same thing but with large grid. And let's just check large rocks dot size. It should be 9 times this times 9. Okay. So large steps, we diff large rocks, and we filter by large area dot inbounds. Okay. Then we take large steps, and it's gonna be max steps. Um, mod 131 area dot width plus area dot width, right? Yeah, it's just one out to the side. Wait, will this cover everything? Some of my calculations will go down to like 0. I think large grid should be 5 by 5. At least. Yeah, let's make it 5 by 5. Exactly like this one here. Right, that way we have all the corners. Otherwise, oh, would you still have? Yeah, you still have one of the large corners and two of the small corners in 3 by 3. So that's fine. Um, and then large steps, that size. Give me something. Will give me an answer. And then what we could do is replace max steps with the same thing here and see if my formula gets the same answer. Hopefully everything down there is like the term defined in terms of max steps. Um, and maybe if it's not, we find an error. And yeah, let's do that. Let's run that. Oh, we have an issue. Long wired int somewhere. I guess this whole thing needs to be turned into int. It'll be fine. Or rather, this is already an int. Let's just do that. We had other issues. Oh, start.copy. Here we go. Or, you know, this can just be a point. Point start.x. This is a large start. Large area dot contains. There we go. Ah, hey there, why JVM? After some time with Python, I actually wish to get back on Scala. Why JVM? Because Scala runs on it. But it'd be nice if that weren't the case, yeah? Oh, wait, not grid. Large area dot width. Oh, no, just a normal area. Area dot width plus area dot height. This is a large start. We're just gonna give it a name. Well, large start. What's that? Okay. So we're finally testing on a 9x9 grid, seeing what answer we get. 34, 310. Okay, and now my formula, which should now be working with a much smaller number of steps. Mm, right, a smaller max steps. Which is exactly this thing here. My formula, which works on that, should give the same answer. It does not give the same answer. 34272. Um, if you take out another 131, let's say we just did 65. Wait, 65. What if this is all just a result of like an off by one kind of a thing? Right? Like it should be one less on all of those. I could just try that. 130. It's still manually. I can make this programmatic. The 64, 195, 130. Um, yeah, I wonder how this would do. We didn't add area dot width back. So this is just 65. Those steps. 65. 65 dot size. We have a bunch of zeros in here that we're multiplying by. So this isn't actually a very helpful test, is it? But it'd be very instructive if it didn't pass. Okay. Step 65 dot size, 3848. Right, this is my thing that's working fine for part one. Pretty sure that's correct. And now if I set max steps to 65, and if everything is properly determined in terms of that 65, which I don't know, I think for just one, yeah, some of these are gonna be wrong. Like these small corners, max grids away is gonna be 0. If max grids away is 0, then this is gonna be gone. Right, so we'd comment that out. Um, do you have the small corners? I think you'd only have the small corners. Is max grids away one too large? One larger than it should be? Let's multiply by 0. Oh, these corner things, these don't exist anymore. They do exist in like 3x3 grid. Let's make sure that this is supposed to work for 3x3 grid. how this work. Let's go over here and let's look at a 3 by 3 grid. And I don't know. I'm gonna leave the left side not completely filled in. So if we take it modulo, then we end up. Should I use a highlighter? No. I'm just gonna use green here. Keeping basically this. So we have one small corner. And we don't have any of the large corners. Max grids away should be 0 in this case. Okay. Yeah. So let's switch this back up here. Large steps of this, 34, 310. So this is in the 9 by 9 grid, which means there are no large corners. Wait, unless we're going like past it. You'd be going past it. We're only going like 131 past it. And the large grid just covers a single extra 131, right? So there's the 30418. So there's a discrepancy, but let's look at why. It's about 4,000 off. Let's look at grids covered. Grids covered should just be 1. Yeah, that's 1. And then max grids away should be 0. Yeah. And top right corner small. So all of these top right, top left corner, whatever. So all we're adding is a normal grid that's fully covered. Odd covering, yeah. Normal grid that's fully covered. And these 4 pointy bits, and these 4 small corners. And this is where we can like modify this, see if we're off by one on one of these things. And again, how did we calculate our new max steps that we were using? We take it mod area.width and then we add an extra area.width back. Does that do it? That does it. What is the difference? So 30418 minus the large steps 34310 minus 34310. So there's a difference of like 900 or something. And one thing I could try is reducing all of these. This is 64 plus 131. So we are under, right? We actually need to be larger. We could try making all of these 131. 131. And then, let's see. Top right corner is big, all this stuff. 196 and 65. This is how we'll fine tune those. Okay, let that run. Not that the small corner values are going to matter here. Now we get 30834. Still too small. Hmm. Oh, hey, coding with strangers. How are you? Thank you for the raid. Thank you for the raid. How's your stream? You didn't start doing Advent Code, did you? Oh, hold on. I missed a chat from Pet Alligator. What were you saying? Why are you multiplying the total grid covered by the odd covering with every other grid and even covering? The even coverings don't matter anymore. So it's every covered grid is odd parity. Um, right? Oh, wrong. Oh. Um, okay, so originally I had things split into odd and even covering. I'm gonna look back into this chat. So close to making this red shell work on my mini game. Oh, cool, cool. AOC is for cool people. Oh, thank you. Um, what was your approach? I gave every grid a label and added a hash to every cell of the visited grids. Eventually, every width steps delta. Okay. So if you have an odd number of steps, let's look at this again. So it's 65 steps to get to the right, right? Where have we done something like this before? Okay, it's 65 steps to get to the right. We'll trace our path in red here. 130 steps to get to the top right corner. And then to get into here, even parity. This is a problem here. I'd counted like going into here as even parity because I was like, oh, well, it takes 65 steps to get here. 66 gets you into there. And it is even parity when you enter. Like ultimately it's going to be not the same parity as whatever's going on in there. Odd number of steps, even number of steps to get into there. Oh, no, no, it's an even number of steps to get into there. It's an even number of steps to get into there. But wait, does this make sense? So if we have an odd parity problem, then in this grid, so let's look at the borders between some grids. So if we're having odd parity, it takes an even number of steps to that corner. This one is highlighted. This one is highlighted. This one is highlighted. This one is highlighted. Okay, I need to add the odd and even back. Um, okay, okay. Let's remove some of these changes I'd had here. We need to split this back up. I have it commented out somewhere. So here's an even covering. And odd grids covered. This is all going to be max grids away. So this is this formula. The same old thing, divide by 2. You know what? I'm going to copy the formula and we'll modify it. Okay. So there are more odd grids covered. The center one is going to be an odd covering, right? So that has a +1. And then the rest are split between 2. So we need to divide this by 2. So we'll put that back to 2 and put this to 2. Cool. And we have an odd covering and we have an even covering. So we have odd grids covered, even grids covered. Leave that commented out. Is this in my answer? Yeah. I'll put it here too for a good reference. Um, Now this shouldn't change anything because, oh wait, odd covering. This is even covering. In a 3x3 grid, I mean in 3 grids by 3 grids, there are no even grids. Well, okay, actually, you know what? The grids to the right. Well, no, we compute. Look, um, let's look at our scratch. So these things that we computed, they should show whether it's odd or even, right? And since they're all kitty corner from each other, they'll all share the same parity. Right, so top left, these small corner grids, these are even parity. Cool. Yeah, these are all even parity because the corner is highlighted. And these things are odd parity. That just happens to be the case. And like I believe it, look, see how those will line up. Should print those in like an order where they show. Right, it goes all the way to the edge. So those are even parity as they ought to be given the number of grids that it crossed over. Right, every time you cross 131, you switch parity. But that doesn't change the fact that my answer is apparently not working for 3x3 grid, which doesn't have parity issues. And you know what? We could see it. We can see the parity differences in here too. This is gonna have odd parity because there are like an even number of things left, right? That should be odd parity. So we know that it's not off by 1. It's off by at least 2 if it's off. This one here should not have the same parity. Well, yeah, it's even parity. And if you're counting 64 from the left, from the bottom left corner. So going from the side and going from the corner give you different parities. And we checked that parity lines up with this. And we checked this. This parity lines up. So this here, odd parity, even parity, odd parity. And since this is a corner, these are both from the corner, and they're different parities. This one should be odd, that should be even. Great. And I think I'd submitted this. I think it was also it was a 6-2. We could try that again. Let's try it. Or the full max distance. Well, max steps. Yeah. odd covering, the even covering, even grids covered, odd grids covered, and we've been over even these calculations multiple times now. Um, Happy to explain this to newcomers if you're trying to keep up here. Like maybe I'll find a bug while explaining it because I've been over it multiple times and it seems solid every time. Um, I'm just waiting for this about I don't know. It seems like that lags out eventually. I'm just gonna restart the worksheet. That so happens that this here is odd parity, and that would make sense if there were an even number. Oh, an even number of grids here that lead between this and the center. Odd parity, even number of grids. Max grids away. Wasn't this value wasn't this value odd? Max grids away is 202,299. And if parity alternates, center grid's just gonna be odd. Um, then we have an odd number. Then the next one, the corner grids are gonna be even. Um, and when you have an odd covering, okay, 62494, 248, 48, whatever here. Yeah, we'd submitted this a while ago. But I'm starting to doubt a thing. Let me look back at the scratch again. When is it? So since it's an even number of steps to get to the corner, if the corner is there, it's even parity. This is odd parity. The center grid would be odd parity. You have an off by one on the number of grids, I think. I think it's actually one too high. Right? Wasn't it saying, okay, like the reason I'd commented something out. Oh, no, not that file. The reason I commented this out here was because max grids away was 0. I mean, that's true. Oh, yeah, this 130 and stuff would only apply to my larger one. Um, how many grids fit inside of this? Grids away. Max steps, we subtract some stuff. What if I just subtracted 1 from this, made this even? Let's check the parity of our center. And we can do that by, where do you go, like odd grids covered, odd covering. Let's show an odd covering. So let's just show 151. And verify its parity. Oh wait, hold on. Um, that's silly. Oh, okay. So an odd parity actually looks like this. Okay, that's not the part I got wrong then. It shares the same parity as the wait, it shares a different parity as the edges. I'm so close to finding whatever my off by one is, if it is. Uh, Copy that worksheet output, go to Scratch. Is it not in the clipboard? Okay, here we go. This is an odd covering, covering after an odd number of steps. Yeah, so that's odd. But the very edges, oh, I don't like this. Why are we printing all those lines? I want to know what that's coming from because that could slow things down a bit. Wait, whoops. What did I do? I didn't type. Okay, we have the original grid. And what's this? We have the large grid, which gets printed. Okay, sure. I want to see. We had like a comma I somewhere. Comma D. Yeah, these. So this is an even parity. The corners are even parity. Hmm. We're not showing the large corners. This is odd parity. And there are 21, 21, or 2023. Divided by area dot width is too long. 22299. I think this is one too large. Or rather, this calculation here could be off. Okay, so we can get here. This should always be this plus 131. Right, the relationship between these, I think is well established. You add 66 to get here. We can go up 64 steps. We missed the center. If we can go extra, then we have to add +4 to everything. It seemed intentional that, I mean, if we take, it should fill that, right? Because if we take 265, 01365, 265, 01365, and we just take that modulo 131. right? There's 65 left over. We have to divide that by 2. Wait, no. No, that is the max number of steps. And we divide that by 131. 202, 300. Yes, you can go 202, 300 grids to the right. Grids worth to the right. And then you can go an additional 65. Or you could go to 65 first, which gets you to the edge of yours. Then you can go 200 to 300,000 grids to the right. And that rightmost one will be an incomplete grid, right? It'll be one of those pointy corner grids that like point to the right, which means 202,299 pieces are in between. That's the number 202,299 grids are in between the start grid and that very edge grid. And we do have 130 left to go if we actually get inside it. Wait, what would we get inside it? We move 65 to the right. And so you have 65. We're moving to the right. Then 202,299 times 131. Full grids. And then we take another step in. So we have 65 plus that, plus 1. And now we're in the left edge. Now we are here, right? This is that plus 1. This dot on the right-hand side here. And then we add 130, and we should get this thing. Okay, so why does it look like these two things have different parity? Because this is an odd number of cells, right? If this is one cell, you'd have even, odd, even. But the first one's odd, so odd, even, odd. So why is the parity off there? Width is, in fact, 131, right? I'm not getting that wrong. Yeah, width and height, both 131. We start at 65, 65. Yeah. Minus 65 gets us the left edge at 0. And plus 65 gets us the right edge at 130. Our area is 0 until 131, which only includes 130. So 0 to 130. But then, why is my parity mismatched? Parity is mismatched because whatever happens, I think I have to call it a day at 4 a.m. Just before 4 a.m. But let's try to figure out this parity issue. right? Odd number of blocks in between. This is odd. Odd number of blocks. This should be even. What does it even look like to be even there? Um, what if this +1 is wrong? What if I should be searching? Well, you add 65, you go to the right edge, right? In fact, let's just print an area search of 65. They do 64 here. Is that a hint? Let's show 65. Go to the right edge. Um, do I need help? Yeah. How long you been watching? You know what my formula is? Seating is very welcome here. Okay, let's see what 65 steps looks like. Wait a second. One. My 0 step be? Okay, it's not by 1. I know where it is. So step 0 shows the person just at that one point, right? Step 0 shows the person just at that one point. All of these are too large by 1. My problem here. All right. So have you done day 2021? There's something I want to try real quick. This is my formula, right? So we have all the grids that are fully covered, um, and the number of possible places in them, right? And then these here are all the edge cases. So the right side, the very right point, the very left point, top and bottom. And these are all the corners. I can show you what they look like here somewhere. So here, right? These are the edges I was talking about, the very right points, and small corners and big corners. So I've computed the number of grids covered in the center and the number of them that should be odd parity and should be even parity. And I've computed like the number of these corners, these small corners and big corners that there should be. And that's where, that this max grids away comes into the formula. And I think I just did a little bit of off by 1 here. This 131 should be 129 because that doesn't mean 130 steps, does it? Oh, no. Yeah, the number of steps you take from a place. And how many steps you have remaining? No, that is. I'm just gonna try it. I'm just gonna try this real quick. We're gonna do a guess and check. We haven't guessed something in a while. Oh, not there. So here, 29, and Top corner is big. Too much is hard coded. 94, 63. And it might be off by 1 in the other direction. We might need to take an extra step. Well, hold on. Yeah, the number of steps taken. So 1, steps 1 should be, yeah, that matches. Because this is working fine for part 1. But what I'm finding, my indicator that there's an issue, is that the parity of these is wrong because there are an odd number of grids between the center grid and this edge grid. So these should have different parities, but this in fact, wait, they should have different parities. We have odd parity. Yeah, we have odd parity on the center. And this one, if we're taking 130 steps into it, that's odd parity. That's an odd parity covering, which we don't want. There should be an even parity covering. So that tells me we're off by 1 on these 3 edge cases here, which is why I switched that up. And here is an answer. On it's still computing. Okay, here's an answer we have not submitted before. So why don't we just try that? Why does it do that? I'm having like flakiness issues with VS Code tonight. Or it's either my keyboard or I'm just like not getting key presses. Did we successfully? Oh, oh yeah, here we are. Okay, this is a new answer I've not submitted yet. Let's try this. Oh no, they're throttling me. Well, that's not the issue. Oh, let's copy that over to the other. So that's not what the issue is. It could be off by 1 in the other direction. Yeah, we'll do that. There is an off by 1. I can't actually explain it. Why there's an off by 1. But I'll like go to sleep. I'll go to bed. And I won't go to sleep because I'll be thinking about this problem. Okay, we wait for that to run. And that is what we'll try submitting. And let's think a little bit harder in the meantime. So this is my formula. How did I come by this number? It's been a while ago. Basically, it was in what are those calculations? In these modulo calculations. Right, so when I take mod area dot width, I get 66. But there are 66 remaining. The max steps, we subtract from our max steps the number of steps it takes to get to the top right. Right? So the top right of the center. And then, we take modulo. So we remove a bunch of 131s. That means, and this comes up to 66. We have 66 steps left from here. Oh, when we step into the bottom left of this one, we have 64 steps left because that's 2 steps away. this number here, dot this to top right, that is 130. Max steps is odd, so that should be an odd number. So this remainder should be even. Yeah, it would be even, which means this corner here should have an even number of steps remaining. And if we do like a simpler calculation, I should just pull this up. So again, what is this? This whole thing divided by 131. There are that many steps, or that many big blocks worth of steps you can take to the right. Oh, we've calculated this. So walk 65 steps to the right border, walk this many steps, or walk this many steps this many times. This is the number of blocks. And step 1 to get into here, right? This dot right here, plus 130. 130 remaining steps. That gets you the original max steps. So that adds up. There are this many blocks. Oh, okay. There are this many blocks. But each block is odd, which means you flip-flop on every block, right? So the center one is odd parity. The center one is odd parity, which I'm not convinced the center one is not odd parity. But it is. The center one's even parity. Okay. Yeah, the centerpiece is even parity. I know exactly what the problem is. Okay, so even grids covered and odd grids covered need to be swapped. Well, even grids covered. Oh, let's undo these changes. 130, 196, 65. Is that right? 130, 195, that's 64 actually. $195. Yeah, that's exactly where it is. The center block, the starting block, is not odd parity. %, that this is an error. And if this is the last error, then this is it. This is what I'm submitting. The odd covering. Oh, wait. Val, odd grids covered. This assumption here. The +1 goes for even grids covered because the center one is even. So there's nothing wrong with the edge pieces. Okay, that makes so much more sense. I think I need to restart my thing. And at this point, you just wait until you're eligible to submit. Okay, wait for that to run. And when that runs, that is our answer right there. In fact, if we can calculate this by hand too in the scratch file. So it'd be whatever our answer was. I think it's this one ending in 48. Yeah. 6199. Okay, so it's this one. Minus an odd covering and plus an even covering. Odd covering. So minus this plus this even covering. This should be my actual answer. Yeah, 6-1. Oh, hold on. There's a slight difference here. Oh, I think I did it to the wrong number. Okay, which of these is right? I did it to 6199, 48, whatever. Okay, I'm gonna copy that worksheet output. Replace scratch. No, I don't know why copying worksheet output doesn't seem to work properly. The output copy to the clipboard. Okay, we'll wait for that. I'm gonna pee real quick. Okay. Okay, I have the output copied here now. Oh, nope, nope, nope. Wait, multiple times. I think it's just slow to did I accidentally copy into my worksheet? Just really slow to paste, I guess. Okay, here we go. The answer. And why is that different? Okay, what I'm gonna do, go back up a few lines here. Plus that, minus that. We'll see what answer it was based off of. We should see another one, 621448. Yeah, this is our answer right here. And as soon as we can submit that, wait. Uh, that's what we just tried to submit. Okay, well, it's 4 a.m. I have to call it a day here. Hmm. Figured out one more thing, which is that this answer was off because of the odd and even covering count. Anything else wrong in here? 130. I'm still pretty confident that this should be 195 and 64 and 130. I'm confident in those numbers. Grids away +1. Small corners. Yeah, okay. Well, we can sleep on this. We'll get it at some point tomorrow. Um, Pet Alligator, I didn't address your comment here. Um, Build a number of plots by induction given n steps. Notice it 131 times 2 steps. Yeah. I see that approach, but I like committed to this one, and I think this is still a good approach. I just don't know where the bug is. Um, all right. Well, thanks everyone for stopping by. Thanks for sticking around this long. But I'm gonna hand you over to someone else. So, um, let's see who's still streaming Advent Code. Which Advent Code? Thanks, I appreciate it. Yeah, I hope y'all understand what it is I'm trying to do. One up time is doing stuff. Cool. Let's join that stream. Check and see how they're doing. And this is
Yeah, it's
the
not like
only
OP.
Advent
I'm
Code option.
mostly joking.
It's interesting.
And you know, if
There
you're
are only
fully
2 of us
automating
on right
that,
now. That seems so weird. There should be
well,
so many more.
oh, I beat him once. Oh,
Everyone else is either smarter than me because they solved it, or smarter than me because they went to bed.
what's day 11?
Okay, grade 1 up time.
All right. Somehow,
Thanks everyone. Have a good night. Good luck with the rest of Advent Code.
yeah. Sometimes you get lucky too. Yeah. What problem was that? Like, I don't even remember it because like it went so fast. I just remember all those problems I spent like 10 hours on. Which one was it? 11. Dude, I seriously don't remember this problem. Oh, just like length finding. Oh yeah, this one. You just had to like multiply stuff, right? This one wasn't too bad though. I think this was just like speed. I doubt. I think I got lucky because I'm guessing like if you did this one using like an iterative approach, like